Okay, folks, we're gonna solve some polynomials. Let me just remind you the zeros are where the polynomial crosses the x-axis. So when you write zeros of a polynomial, you put your answer in brackets. So if I have a polynomial that is, say it's factored, and the polynomial looks like this. Okay, that's in factored form. If I set each of those factors equal to 0, I would get the x-intercepts, or where it crosses the x-axis. So I could see it would cross at -3, +1, and -2. Okay, so we are going to find zeros by looking at a graph, by factoring, and then also using the rational zeros theorem, which is, we're going to use synthetic division. So I'll remind you how to do that. So if you're asked to find all the x-intercepts of the function and express your answer as a list of x values, sometimes just factoring is all you have to do. So when I look at each of these terms, I can see that I could take out a -5 from each term, and I could take out an x squared from each term. So when I do that, I get 9x squared plus 12x minus 4. Plus 4, actually. All right, so now I can still factor this trinomial further. 9x squared could be 3x and 3x. 4 could be 2 and 2, because remember, I'm trying to get it to add up to 12 in the middle. And that just actually works nicely because you get 6x and 6x. Remember, for factoring a trinomial, you could figure out what multiplies to give 36, but adds to give 12, and that is going to be 6 and 6. So you could factor that by grouping. Okay, if you learned how to factor by grouping, you could use that method too. So now if I'm trying to find the zeros, I need to set each factor equal to 0 and solve. 3x plus 2 equals to 0 just one time because there's 2 of them. So this is going to be x equals 0. This is going to be x equals -2/3 when you solve for x. So when you write your solutions, you put it in brackets, and there would be your zeros. Let's do another one. When I look at this, I don't see anything in common. But there's 4 terms, so maybe I can factor by grouping. By grouping means you look at the first 2 terms and take out what's in common. So I could take out a -x squared. If I do that, I'm left with 3x minus or plus 8. And in the second one, I could take out a -9. Again, I'd be left with 3x plus 8. Remember, when you factor by grouping, you want the same thing to be in the parentheses. So then I'm going to group the -x squared minus 9 together. That's one factor. And the 3x plus 8 together. So I can set each of those factors equal to 0. -x squared minus 9 equals 0. Gives me -x squared is +9. X squared is -9. Square rooting a negative, remember, is going to give me 2 solutions, and it's going to involve I, so I'm going to have plus or minus 3I for my solutions there. My other factor, when I set that equal to 0, I'm going to get -8/3. So my answers, -8/3 is the real solution, and then the imaginary number is, or numbers is plus or minus 3I. Root of -1, remember, is I. Okay, so evaluate using synthetic division. If you know a 0, so here they're saying -1 is the 0, you put that outside the box, and the box looks like this. You take the coefficients, so I have 4, -12, -1, and 15. You bring down the 4 to the bottom, and then you multiply it times the -1. and put that under, under the second column. You add those together, multiply again, add, multiply. When you get 0 in the denominator, that means that -1 is in fact a 0 of the polynomial. So it would cross, one of the spots it would cross at is -1. The degree is kind of key when you have a polynomial. That's the most number of times the graph can cross the x-axis. All right, use synthetic division to show that x equals 2 is a solution. I just wanted to show you synthetic again to jar your memory. I bring down 10, I multiply and get 20. Then I add those together, get 5, 10, -6, -12. When your answer is 0 at the end, that means that I, in fact, showed that x equals 2 is a solution. All right, here's what the assignment is going to look like in Delta Math. They're going to give you a factor, oops, and then ask you to find all of the zeros from that factor. So that means that I'm first going to take that factor, set it equal to 0, and solve. So I get -1 is a 0. So I already know -1 is 1, 0. Then I'm going to do synthetic division. Bring down the 1. Then I get -1, -6, 6, -12, -16, sorry, and then 16, so I get 0. Now, what I have left down below, because this is a degree 3 polynomial, what I have down below is now a degree 2 polynomial. So 1x squared minus 6x plus 16 times the x plus 1 factor would equal that original polynomial. So if I set this quadratic equal to 0 and solve, that'll give me the other two zeros. You can do the quadratic formula or factor if it's factorable. So, oh, here we go. X times x gives me x squared, and -8 and +2 gives me not the correct answer because it's -16. Oh, it's -16. Oh my goodness. Yeah, so that is the correct answer. So now I have those two factors plus my original factor. If I set each of those equal to 0, I get zeros of -1, +8, and -2. I just want to do one more to make sure we're on the same page here. Okay, so x minus 2 is a factor, so that means I'm going to put 2 as one of the zeros and do synthetic division. 2, -12, 26, -20. I use each of those coefficients. Bring down the 2, I get 4, -8, -16, 10, 20, 0. So now I have 2x squared minus 8x plus 10. That's my quadratic. I'm going to actually do the quadratic formula just to show you that that always works. So negative of b is 8 plus or minus square root. B squared is 64 minus 4 times 2 times 10 divided by 2 times 2. So what is under that radical? If I take 64 minus 80, then that's going to give me -16 under the radical. So that would be 4i. When you have something in common in each term there, I can take out. So what I get is 2 plus or minus I as my other two solutions. When I go back up here, I have one real solution and two imaginary. So go to Delta Math, reach out if you have questions. You're going to do the finding. Oh, that's just like x-intercepts. in unfactored form and then do the synthetic division to find the zeros. What's the puzzle? Home on the range.